One of my favorite verbs is scamper. A squirrel scampers back and forth across a log. Let S equal 0 represent the place where it has stashed its acorns, where S is measured in meters. Mammalogists, those are people that study mammals, have modeled the erratic movement of the squirrel with the function shown here for that time, and the function is graphed below. Okay, all right, let's figure out what this squirrel is doing. Well, this squirrel is scampering back and forth, and S equals 0 is where it has stashed its acorns. So there's a log. I'm terrible at drawing this, but we're going to try. So here's a log. And there we go. And there's a little purple squirrel, and he's scampering back and forth. And well, let's number it in green. At 0, that's where he stashed his acorns. Now, he gets pretty far back. He goes back to -4 at one point, or at 2 points. And he goes up to about +2 point something. There we go. All right, and there's a little squirrel, and he scampers back and forth. So I was about to draw him in purple, but then you'd make fun of the way my squirrel looks. So here we go. There's your squirrel. He's driving an orange sports car across a log. And let's kind of talk about what happens. So 0 seconds have elapsed. Where is your squirrel? Your squirrel is at -4. Your squirrel is scampering, and there he is right there. And at the end of 1 second, your squirrel is at position 0. This is where he has stashed his acorns. So there's a little stash of acorns right here. They're blue. There's the stash. There we go. It's like a little hole in the log. He stashed his acorns right there, okay? So it took him 1 second to travel from here to here, 4 meters. Pretty fast little squirrel. So check this out. Check this out. From here to here, he traveled from a position of -4 to 0. Then he travels forward. And then he travels back, and he is back at his little stash of acorns at 4 seconds, 1, 2, 3, 4, with a position of 0, and then scampers back to the position of -4 for the last second. Okay? All right, let's let him drive the orange car. He won't be a purple squirrel. He'll just drive an orange car. Here's what's happening. Here's your squirrel. 0 seconds, 1 second, 2 seconds, about 2.5 seconds, 3 seconds, 4 seconds, 5 seconds. Okay, I hope that you were watching this and looking at the graph too. If it helps, you could make a table. We'll make that purple. So T and S of T. So 0, 1, 2, 3, 4, 5. And he's at -4 here, -4 here, 0 and 0 here, and at 2 and 2 there. And in between time of 2 and 3 seconds, he reaches his furthest to the right position. Okay, now write a brief description of the path of the squirrel, including approximate distances and travel times. So let's go. He travels. You want to give him a name? I'm thinking. I'm going to call him Chompers. If I could spell. Chompers the squirrel. Chompers the squirrel. Ooh, goodness, having a hard time spelling. Hands getting ahead of my brain. Chompers the squirrel travels to the right. Beginning at, woo, my hand is really getting ahead of my brain. Beginning at position of -4. He passes his stash of acorns at t equals 1 second, and turns around or starts running backwards or something at t equals 2.5 seconds. And at that point, he had reached his distance, furthest distance to the right, and it was 2 point something. We don't know exactly what. Chompers then runs to the left, passing his stash at t equals 4 seconds, and ending at s equals -4 at t equals 5 seconds. Okay. Ooh, too many s's on seconds. I just couldn't quit writing it. I promise I can spell. Sometimes I'm thinking of one thing. Was it too many s's? I think it was. Yeah. I'm doing more than one thing at a time, and spelling isn't one of them. Okay, again, here goes Chompers. He travels, he turns around. Let's not make it harder than it was. All right? At what t values in the interval is the squirrel at his acorn stash? We actually just answered that, so the rest of these questions will go a little bit faster, and they will be at 2 different times, and that would be here, and that is t equals 1 and t equals 4. T equals 1 and 4. Let's put units on this just for fun. Seconds, spelled correctly. Find the velocity function. Okay, the velocity, we saw this in the first part of the problem, the first part of the lesson. The velocity is the rate of change of the position. So I'm going to say that the velocity is equal to whatever, the derivative of s. But I do want to be very clear that I'm taking the derivative of s and not just saying, hey, velocity equals whatever. I need the people that grade my paper to know that I'm not just saying velocity equals whatever. I'm actually taking the derivative of displacement. And I will get -2t plus 5. -2t plus 5. Okay, determine at what t values the squirrel is at rest, which we actually figured that out. We said that squirrel turns around at t equals 2.5 seconds, and we saw that here. But it is at that point that the squirrel is at rest. So Chompers turns around here. Chompers' velocity is 0. Okay, let's think about this in terms of a tangent line. The line tangent to his position function. This is his position function. The line tangent would be positive, have a positive slope here and a negative slope here. But it would have a slope of 0 here. And there is where the velocity, there's your velocity, equals 0, and that would be at 2.5 seconds. Okay, sketch the derivative on the same graph as s of t. Sketch the derivative, the velocity, basically. So we're going to draw the derivative, and we're going to find a few little cool things about it. We're going to draw it in red. So if I was to graph -2t plus 5, then I would have a y-intercept of 5 and a slope of -2. So there we go. There it is. There it is. All right, so we're going to make some connections. Ooh, I shouldn't put an arrow there. It starts at 0 and ends at 5, so let's not extend this thing too far. Okay, that'd be an open interval if you want to get technical about it. All right, here we go. Let's make a couple observations. Remember just a second ago when I said if I drew a line tangent to the parabola, here we would have a positive slope. So notice that the graph that I just drew, although it doesn't have a positive slope, it is positive for this interval, okay? Notice, parabola is going up, so the red line is positive. Red line is decreasing, but the red line is positive, okay? Don't mix up the increase, decreasing, positive, and negative, right? Okay, The squirrel is running back this way at this point. The slope is negative. So when I graphed the derivative, I got negative. I got something below the x-axis. And exactly at that point, at 2.5, at t equals 2.5, the squirrel is at rest because the squirrel turned around at that point. All right, let's keep going. Number 6, find the velocity of the squirrel at t equals 3 seconds and include units. Okay, well, this shouldn't be too hard. So I need the velocity at 3, and the velocity at 3 would be negative 2 times 3 plus 5, which is negative 6 plus 5, which is negative 1. Okay, well, what are we dealing with? Well, normally the position of the squirrel would be shown to be meters, right? But we're dealing with the rate of change of that, and the time is seconds. So this is negative 1 meters per second. Not so bad. Find the acceleration function. Okay, well, if we take the derivative of velocity, we'll get acceleration. And the derivative of negative 2t plus 5 is negative 2. And let's do number 8. Determine the acceleration of the squirrel at t equals 3 seconds. This is super easy. A of 3 equals, well, it's negative 2. Doesn't matter what I plug in here. I'm going to get negative 2. And include units, okay? Well, the rate of change of meters per second would be meters per second per second. Okay, this is confusing, but basically my meters per second is changing at a rate per second. You could also reword that to be meters per second squared. It's the same thing. And then, is the squirrel speeding up or slowing down at t equals 3 seconds? And explain your reasoning. Okay, the squirrel will be speeding up when velocity and acceleration have the same sign, and slowing down when velocity and acceleration have different signs. Let's figure it out. Because the velocity at 3 was negative, and the acceleration at 3 was negative, they both have the same sign. I'm going to get a little technical here. We can do that. You don't have to, but I did. And so Chompers, the squirrel, we'll just say the squirrel, I didn't capitalize the beginning of my sentence there, now I did, is speeding up because, speeding up at t equals 3, because v of 3 and a of 3 are both negative.